Okay, let's go back to that. PubMed. Where was it? Yeah, here. Circulation, for example. And then search. I want you guys all to do this. Circulation, yeah. Meta-analysis. Now, can you see the range? I'm going to change the range. (2021). And then I get these meta-analysis, and then what I can do is I can test them and see if any of them is useful. This one, for example, is a good one. Although one of my colleagues actually repeated this one recently. But this, for example, you look at it, and let's just see how many papers they've got. 23 studies were included. So this would actually be quite a good one. Although one of my colleagues has recently repeated it. But something like this would actually be a good one if it wasn't repeated before. Yeah. So these are big journals. You always want to publish in the biggest possible journals. Yeah. Guys, are you guys doing well with this exercise? Have you guys done it? Anybody having any issues with this? Fine. Advanced search. Yeah, guys? Any issues? The silence is deafening. You guys are all doing it? Just guys, is it working for you, this exercise?
Yeah, it's working.
Very good, very good. This is how you find your topic. Okay, this is my data. This one, for example, is pretty good. So coconut oil. Then you go in. And this is good. For example, so this one actually, if any of you guys want to do this, is a pretty good one. So 16 trials were included in the meta-analysis. So I look at 2 or 3 things. So to see this is usable. One is I go straight to the number of papers that were included. And that one, in that case, this is about, I think it was 18. Here it is. 18 trials. So that's not too big. Yeah. It's a big topic, coconut oil. And then I go to the search, which is the second big bit. Because the search, you want to see how many studies were included, how many were excluded. 873 articles. So the search is not too big, because if it's like 4,000 or 5,000, then it's not doable. This is 70 for it takes about an hour to look at 60 to 70 abstracts. So this is not too bad. Yeah, this is not too bad at all. Okay? So this is how you would find your topic. Is that clear to everybody? Yeah. And then you would look to see if there are 2 new papers, which you can do is just a general PubMed search. You can search coconut oil, and then it will find your new search. Is that clear to everybody? Yes?
Yeah.
Okay, fine. All right. Now that is the topic. And then let's find the next YouTube video. Which I show you. Why is it being so slow? Let's come back to this video. Let's go on this playlist. No, we don't know why it's that in German. It's quite funny. Went to this German thingy. Maybe I can switch it. And then, don't know why I did that. So this is the channel. It's got all these videos explaining every single aspect of meta-analysis in great detail. Actually, it's not as easy to search as I thought. Okay, now we're going to do something interesting, which is, let me just bring up the channel first. Now, just to take you through it a little bit, basically it is about all aspects of meta-analysis. So this is there's a playlist here. You can watch these videos later. Like, so there's things like deciding the topic, which we just covered, then making a protocol. Now the protocol you can make through a GPT, and the GPT is basically a GPT called Protocol 4. Meta Protocol 4.0. It will actually generate a really nice protocol for you. Okay, which is pretty good. And I'll just show you quickly how you do that. Okay. So this is, you can take the previous protocol and then you put it in this GPT, which is called Meta Protocol Assistant 4.0. This is actually it's gone through a lot of versions. It's very specifically designed to basically give you a new protocol. Yeah, and protocols, every meta-analysis nowadays has to have a protocol, and you register it on something called Prospero. And this is, if you register on Prospero, you have a 70-80% chance of success. This is a very, very powerful way of doing your, being more likely to be successful in your meta-analysis. Yeah, so Prospero is a website. So what you do is you change the intro, and that should give you a really, really powerful. Now, after that, your next step is your search. In your search, what you do is you go to Ovid Medline, and with Ovid Medline, you just select Embase and Medline. Yeah, and then you can go into your Open Athens account. And then you can do your search. Now, the search, try and keep in mind what you want is 2 or 3 things for the search. You don't want too many abstracts. You want like 600-700, not too few as well. If you got 20-30, then obviously you're doing something wrong as well. But you use a combination of terms. So, for example, in this case, the combination of terms is for atrial fibrillation, outcomes, and ICD, I think, was the third one for that one. And then it will bring up all these abstracts. What you can do is you can export all of them to something using something a RIS file to something called Rayan, and Rayan is where you can do your schema. Yeah, and that then you can take your blinding off. This is very important. Otherwise, nobody can see what they're doing. And then 2 people need to screen each abstract. Yeah, and then you can see which 2 people did it. This would be your next step. Yeah, you have your 600-700 abstracts, and then you move on to your next step. Okay, so that was one video. Oops. Okay, so now, then the next bit is something called Pico. Okay, now Pico means participants, intervention, control, outcomes. This is very important. This is a definition of a meta-analysis. So, for example, participants in this case, this is a very good study by one of my colleagues, Jonathan Bray, is adults who can have SGL2, including patients with diabetes, CCF, CKD. Yeah, so that's participants. Then, the next one, you see intervention, so which is SGL2 medications. Yeah, then the next one is control. Control in this case is any control. Yeah? So all of that is actually you have to give, and then outcomes. What were the outcomes? Yeah, primary outcome is in this case measurement of inflammation, and then you talk about what sort of studies you want, RCTs in this case. And then they said all observation studies, case reports, science reports are all excluded. Yeah. So you need to have a very clear PICO, because if you don't have a clear inclusion exclusion criteria, then you can't do the study. Okay. Now the next, this is interesting. Let me show you the various GPTs we have that will help you with your tasks. These are the GPTs which have been developed. They're all on the GPT store. So this, you click on Explore GPTs in ChatGPT. This is your protocol assistant, write the protocol for you in a very, very advanced form. It tells you outcomes, everything. Yeah. So you submit on Prospero. Write your own intro because you don't want to use ChatGPT's intro. Yeah. You can use the start spec. Okay. You can create a demographics and outcome sheet with it as well. You've got another one which is called a Prisma flow assistant. What is a Prisma chart? A Prisma chart is how you record your screening. So, this is a documentation of your screening, and this assistant is pretty good and it will help you with your Prisma flow chart. Then there are these risk of bias GPTs. You would think, what is risk of bias? We'll go through why risk of bias is important, but it's just a quality control for the papers. And there are these GPTs, which are extremely advanced, which can help you with risk of bias for every single one of your papers. So there's GPTs which can do observational studies. These are like cohort studies. Cohort studies means that on one side you have you don't have a randomized control trial. It's just a population set that's been collected in hospital. Okay, and these are the different GPTs. 786 Robin's Eye, and then risk of bias GPTs. These are all on the GPT store. You can use them. Risk of bias 1, risk of bias 2. These are for randomized control trials. Oh, very, very powerful. Okay, let me show you some more exciting videos. Okay, let's go back to the channel. Guys, any questions about this so far? Let's go back to the channel. If it lets me. Okay, so I'm going to show you a little bit about this. Oh, let's go to the show. Okay, so as we show you to meta-analysis in less than a minute. Combine, what is a meta-analysis? Combine results from many studies in the same topic. You do weighting. Each study is weighted based on their quality and size. It helps researchers identify trends or heterogeneity, which is differences between you comparing apples to apples or you comparing apples to oranges. You use forest plots. This is something you can do in minute. Okay. Now, let's go back to our playlist. Okay. Now, search. Just do a bit about searching now. So we did this. Now, Ovid Medline searching. So Ovid Medline allows you to search both Ovid and Medline together. Medline's got 31 million references. Embase has got 28 million references. You have to search both and then use something called reduplicate. It reduces the number of papers significantly. It's very, very important. Yeah, open Athens. Then search. So for example, in this case, I put in Brugada. Yeah, and then I put in ICD and defibrillator. Now we use OR to combine those two terms. So if the terms are similar, we combine them with OR. And then what we do is this creates a new option. Then you combine this. So Brugada, it must be patients with Brugada and ICD or defibrillator. Yeah. And then you get far fewer results. Then you think, well, I've still got a ton, 3,200. So then what you use the word outcomes to reduce your number of papers. So 10% of Cochrane reviews, for example, have outcomes in their literature search. You combine outcomes and that sorts out the problem. Yeah. So this usually works quite well. Guys, I've been talking for a little while. Any questions so far? Any questions about this? Guys? The silence is deafening. Any questions so far? No? Anybody have questions? Taylor, Ahmed, Michaela, Sankavi, any questions? Or let me just see if somebody's written in the chat.
Just to ask about, how choosing a topic and things to
Yeah.
avoid it being the exact same as what we came up with in the search results. Like, are we changing like the years or what are we doing?
So you are adding in new papers. That's probably the most critical bit. That you're adding in new papers. It has to be statistically significant. So in essence, you have to find at least 2 new papers since the last meta-analysis. Yeah? If there are 2 new papers since the last meta-analysis, that means you've got enough. And you can do it. Yeah? You can actually do it. Now, so we did the GPTs. And now let's do the screening a little bit about how do you screening. Today we're just doing an overview. So screening. So you create a new project. Oh yeah, this was made by my daughter Nadia. She's quite good at this stuff. So upload the RS file. Invite your screen is to Rhea. It's quite important. You have to get the email addresses. Circulate your inclusion criteria and exclusion criteria. Be very clear on this because this will otherwise it will become a disaster. Yeah. And then let's look for part 2. So take out blinding. Everybody can see what others are doing. Each abstract should only be screened by 2 people. And then first include papers from previous meta-analysis. Now this is quite important. It's understated step. These include, make sure you've included the papers from previous meta-analysis. You don't want to exclude them. Yeah. Okay. Then if you're doing screening, a quick way of doing screening is search for terms like case reports and exclude. Look for animal studies and exclude. Look for reviews and exclude. Yeah. These are quick ways of screening large numbers of abstracts. And if any conflicts, then a third person decides. Okay. Let's go back. Okay. So going back to our playlist. Now you document your review, your what you've done through something called Prisma. This is very, very important. Now, if you look at the channel, there are actually examples of how you should search, but I didn't want to go through them too much. But we can go into the Prisma table because that's quite important. And I'll show you a bit about why this is very good. This is one of the most critical aspects of your meta-analysis is the Prisma table. Yeah, this is they will look at this. So in the total number for each database, how much did you get for Embase? How much did you get for Medline? How much did you get from each database has to be given. Then how many duplicates were removed? Okay, so there's a reduplicate function. So you see how many duplicates were removed. Then how many screen, not basically you just give how many were excluded. Yeah, how many basically after duplicates, how many were screened. And then after that, full text screen. Now, full text screening, now I know they've documented extensively here, but this is not necessary. What is necessary is why the full text were excluded. You need to document this very, very clearly. Why excluded and give reasons why. Yeah, this is quite important. And then you give your numbers in the final analysis. Okay. Yeah. So this, how many final studies were excluded? This is absolutely critical. Yeah. That you give this, otherwise they will tear your meta-analysis apart because they said that you failed at the screening phase. So you need to give why the full text were excluded. That's absolutely critical. Okay, let's go back a bit. That was quite critical. And then let me show you one more. And then the interesting bit, which is how you're going to do your data extraction. Now, data extraction has become really easy because in data extraction now you have Notebook LLM. Notebook LLM is amazing because it allows you to extract data and you put it in Notebook LLM, and then you say, oh, I need the total number of males. And then it would say, well, this is what they are. And then you click on this number one, the reference number, I show you where it found it in the paper. That is amazing because it allows you to extract large amounts of data. Okay, so Notebook LLM, that is absolutely the future for this. Now I won't cover the demographics table. I want to show you how you can create a forest plot really, really fast. Or actually, since it's displaying here, it's got nice music. Let's have a look at it. So this is the demographics table. This is your first table. Second table after the Prisma table. This is the study. Where is it from? What sort of participants? Age, sex, and some other data. Don't overextend it. In this case, it was author, year, country, type of patient, procedure, number of patients. But don't overdo your demographics table. A lot of people overdo it. It's got massive amounts of data, and it takes a long, long time to collect that. So I'm not sure why people spend so much time on a demographics table because it's actually not the main analysis. Yeah, it's not the main analysis. This is another one. As you can see, it's fairly straightforward and simple. Author, year, number, country, follow-up, outcome measure, study design, study populations. These are simple, straightforward demographics tables, which is personally what I like. So in this case, it's author, year, number, country, follow-up, outcomes, study design, study population. Now, this is what I call a population table. These are much more detailed. You can see it's got a lot of detail about, the type of population. I'm not completely sure about it, that you should do to this degree, but you can if you want. So in short, don't overdo the population table process. Don't overdo it. Because if you spend all your time doing this, you won't have time for your meta-analysis. Okay? Okay. And then let me show you the GPTs themselves. Not the GPTs. Okay. Now, two aspects. One is, how do you do your forest plots? I'll show you how. Okay, let me just do the forest plots. Yeah, this one is very, very important. And I don't know if you'll have time for this exercise today. You can probably do it offline, but this is important. So let's say I'm going to give you 4 papers here. I think, but the best thing to do is, because we're near the end of the class, is you guys do this offline using this video. So this is a forest plot picked from a paper. This is MRA versus placebo in patients with or without heart failure. And I'm trying to recreate this. And what I did is I actually went and found the original papers. This is the first paper. I took the data out from this, eplerenone versus placebo. Yeah. And then I took the data out from the second paper. It's here. Yeah. This compares eplerenone, placebo, and, positions, death, etc. This is the third data. Yeah, these are all what we call risk ratios in a control group and an intervention group. We've got now 3 and the 4th paper, which I also found and managed to extract the data from. So I've tried to recreate this. Then you can put this into what is called a CSV file. A CSV file is basically a file without any formatting whatsoever. So this has author, event control, event intervention, total intervention. Yeah. So this is basically got all the numbers for each of these: event, total, event and control, and total control, event intervention, total intervention. And then you go to this tiny URL, risk ratio meta, upload the file, and then you can make your forest plot. Yeah. So because we're near the end of the session, we probably will do this next time, is to generate your first plot. But it's ridiculously easy. Yeah, it's so easy to generate your forest plot with this. And not only can you generate it, this app is very, very powerful. Actually, what I'm going to do is I'm going to quickly show you the app, because this will make doing a meta-analysis really, really easy for you. And then we'll stop because we're at the end. This app is incredibly powerful, and I will show you in a minute why I said that. Okay, I go here, go to the app. This is easily available on the internet. And then let's go here. So I go to this. And let's say, oh, does it have the CSV file? Did we save the CSV file here? Did I save? Okay, maybe I didn't. Okay, fine. Anyway, don't worry about it. But in essence, you can recreate that from the, that video, because you can create your own CSV file. You can create your own CSV file and go from there. Yeah, but the app can actually do it. It's extremely powerful. And let me just show you a few sections of it so you understand how it works. Let me do the most advanced version. This is the most advanced version. This one is the most advanced version. And it can do amazing stuff. So not only can it generate the forest plot for you from a little bit of data, yeah, but it can also it can generate the forest plot for you, but it can also give you some meta text results. You can take those and put in the result writer GPT, which is on the GPTs, and it will write your results for you. There are also GPTs that can help you write the intro, the discussion, the limitations. They don't write it for you. They give you the references and they give you the codes. So it's all extremely powerful. But this can generate the forest plot I showed you for you. And not only that, you can change every bit of it. You can change the colors. You can change every aspect of this forest plot. You can change the range. You can do everything to it. You can label it. You can change the plot height, the plot width. You can download it. You can have different types of forest plots. And you can do all this other fancy stats, which is not that important because you end up doing only a tiny bit of this. Okay. All right. I'm going to stop now. Oh, I'm going to stop now. And just any questions, guys? Oh, let me go into the chat. I'll look at the chat. Oh, Anas has kindly put it out in there. Oh yeah, he's put out the thingy. Actually, you know what? I can just use this. Let me use Anas's file. That's very kind of him. Oh. No. Why is it not selecting? Oh no, I can make this bigger, the chat, and then I can select it. Here. So let's say this is the file. And then what I can do is, can I save this as a CSV file here? This is a Chromebook, so I'm not as familiar with it. Oh no, this is a bit tricky because it's fine, it's fine. We'll stop now because that's a bit tricky to take the CSV file. I usually have it saved, but it's interesting enough not saved on this computer at the moment. Okay, all right. Any questions, guys? Last minute questions? Yes, you have a question? No? Nobody has a question? Everybody's understood? Huh? What question do you have?
What game mode did they like it? Look.
Oh yeah, they only played one game mode, so they didn't like one game mode. Okay, fine. Okay, guys, no questions. Everybody happy? The silence is deafening. Thank you. All right. Okay, guys, I'll stop now. Thank you very much. Okay, bye.